And we're coming up to, here we are, 1:35 now to launch. A quick word about the launch sequence. On Ariane 5, we have a 7-second delay between ignition and liftoff. That's because we start the Vulcan engine first and wait for 7 seconds to check it's working before we ignite the boosters. We're now waiting for the range operations manager to announce the 1 minute to launch moment.
À tous de DDO, attention pour moins 1 minute.
We are 1 minute to launch. Switching to onboard.
moins 1 minute.
Switching to onboard power. We are live at the Guyana Space Center for the launch of ATV-5 Georges Lemaitre for the European Space Agency, built by Airbus Defence and Space. Our very best wishes to our customers and to everybody who has worked so hard to bring us to today's launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des 2 EAP et décollage. Tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux, la propulsion est nominale.
And we're off. Ariane 5 powering out into the night sky here at the Guyana Space Center. That streak of gold coming from those 2 powerful boosters. Just catching the sound of that now here, 15 kilometers from the pad as she flies over. And ATV Georges Lemaitre is on its way. Destination, our human outpost in space, the International Space Station. People in the viewing stations will have felt the ground shake. I've sent Charlotte out to go and watch the launch in real life rather than on the screens here, so we'll wait to hear how she experienced it. Right now, the boosters are doing all the work. They're literally pushing us away from the Earth's gravity. That's what keeps us stuck to our planet. Makes it very difficult to leave as well. And we may get lucky and see those boosters falling away there with the naked eye. Each one is burning 2 tons of propellant. That's an awful lot of propellant per second. 2 tons per second. Just to give you an idea, if you filled your car once a week, that's just about the amount that you would be using in a year.
Séparation des étages d'accélération à poudre.
And we did see them separating there. Superb sight, the boosters falling away. And this, there we go, the 2 dots on either side and the white dot in the middle is the Vulcan engine that you can see, and those boosters falling back down. We're shedding weight, we don't need them anymore. We're losing each stage of the vehicle once it's burnt up its fuel, because of course the lighter we are, the faster we go. Right now we've lost about 3/4 of our weight in just over 2 minutes. So right now the main stage is doing all the work, and you can see its Vulcan engine there. That's the white dot in the middle, and still a dot of booster falling away to the left of the screen. Everything's going according to plan, he says. If you look at the bottom left, you can see our altitude is 106 kilometers above the Earth. We are at a distance of 232 kilometers if you were to draw a straight line, and our speed is 2.5 kilometers per second. We're now losing the fairing, and Charlotte has just come back into the commentary box, having seen her baby take off into space. How did you feel?
That was quite something. It's better if I turn the microphone on. That was quite something. It was absolutely spectacular, and I still got
Fin des manœuvres de rattrapage suite à la séparation de la coiffe. Tous les paramètres à bord sont normaux.
I got the blazing lights of the boosters in my eyes. It was fabulous.
You've got the retinal imprint.
Yes.
And what about the sound? And what about the...
Impressive. Absolutely impressive. No chance anybody in this area could miss that.
People quite frequently go to the beach to watch it. Charlotte, let's just tell everybody about the curve on the top right-hand side of the screen. What are we looking at here?
Yes. The green curve is the calculated curve, so this is the expected trajectory, and the yellow overlay is the actual trajectory as calculated from what we're getting from Ariane.
And if you look on the picture on the... He's saying everything's going well and according to plan. And on the right-hand side of the screen there in the middle, you can see the image. We can actually see ATV for the first time now. And these are computer-generated images that we're looking at, Charlotte.
Yes, we know what's happening, or we know what should be happening every minute and every second of the flight, but of course we have no cameras to show it to us. So we have this excellent animated view of what's going on up in space right now. And in parallel, the Ariane launcher is transmitting telemetry down to the telemetry stations here in French Guiana, and this includes the various mission events which are being reported by the DDO.
And here at the Guyana Space Centre, it's been a very busy time. We've already had 6 launches this year. Today's our 7th, and we're preparing more.
And welcome back for a quick update from Mission Control Houston, as we've been watching and following along the flight so far of ATV-5 and the Arianespace rocket, launching it into orbit, going by the book. So far, the solid rocket boosters have done their job for the initial liftoff to escape the Earth's gravity well, as you were hearing the commentator explaining. They've since broken away, doing their job successfully. The fairing peeling back from the vehicle, revealing ATV-5 to the environment of launch. Just about 2 minutes or so away from that main engine cutoff. Shortly following that after will be the ignition of the upper stage. It'll first ignite for a burn of about 8 minutes and 9 seconds to send ATV into its initial elliptical orbit. Following that, it'll shut down and coast for a while, doing a ballistic coasting path until reigniting to continue to raise the orbit. But again, everything going as planned so far. A successful launch from the Guyana spaceport, sending ATV-5 on its way towards the International Space Station. Now we'll go back to the live coverage down in Kourou.
Launcher using ground stations as she flies over. It's called telemetry, and we're going to be picking up the signal shortly at SNA, which is a boat in the Atlantic. Tell us a bit more about telemetry, Charlotte.
Well, the launcher has computer systems on board that are collecting all the essential parameters. And a subset of this is being analyzed in real time as it comes down via the telemetry ground stations. And this is the data that is used to immediately assess the performance of the launcher. And this includes also the reporting of the events I mentioned earlier. So this allows us to, or the launch team, to know what's going on.
And our flight path tonight takes us out across the Atlantic. And we are travelling northeast across the Atlantic, heading towards Paris. We'll then travel across northern Europe, down across India, Indonesia, and down towards Australia, where we will start the process of separating ATV. Which ground stations are we using?
The ground stations that are being used for this particular flight start with Galileo here in French Guiana, the boat that we have spoken about earlier, Station Navale Ariane.
Tous les paramètres à bord sont normaux, la propulsion est nominale.
And then next in line will be Santa Maria in the Azores. And after that, it will be handed over to the radar in Brittany, after which it will be in the visibility of Azaguel near Toulouse. Then there will be a gap in telemetry, because there's no station within visibility, and this will last roughly 45 minutes, after which it will be picked up by
Extinction de
Adelaide.
l'étage principal cryotechnique.
So the main stage has now switched off its engine, it's falling away, and we are igniting the engine on the upper stage, and this is a crucial part in the flight.
Séparation de l'étage. Allumage de l'étage à propergol stockable.
Yes, there was the announcement.
We have the announcement, thank you. So we're now burning the upper stage. Its job is to deliver ATV-5 to its separation orbit. That's 260 kilometers above the Earth.
Tous les paramètres à bord sont normaux. Fin du rattrapage suite à la séparation.
And after that, ATV will climb on its own to the ISS. That's around about 420 kilometers. Charlotte, we're going to be reigniting our engine several times tonight, aren't we?
Yes. And the reason for this is that for the ATV, we are targeting a circular orbit, 260 by 260 kilometers. And therefore, it needs to be reignited one more time later during the mission here. And then there will actually be a third ignition of the upper stage in order to deorbit it safely. But this takes place only after the separation of ATV.
Using a storable propellant upper stage, which is why you didn't see the cryogenic arms during the launch. Often we use the cryogenic upper stage.
Yeah.
So here's a replay, Charlotte, of the launch that you saw earlier when you went outside to watch. Ariane taking off into the night sky.
It was absolutely brilliant. It lit up the entire sky. It was quite amazing to see it.
And it makes the night sky look like daytime, doesn't it, when it takes off, because the light is so tremendous.
Yeah, well, it certainly stayed on my retina, as you said. And here it comes again. I think this video is going to be watched quite a few times in the coming weeks and months. It's really a credit to the Arianespace teams.
And of course, with the support of Guyane Premiere, the television crews here in French Guiana. That was 11 minutes and 9 seconds ago. Countdown on the top right-hand side of your screen there. So we've been meeting the teams at the Guyana Space Centre. There's another team involved in the launch right now. Of course, it's the ATV-CC, the people in Toulouse. What are they doing right now?
Well, the first teams came on console about 16 hours before liftoff.
La pression dans le réservoir est conforme à l'attendu. Le pilotage est calme. Tous les paramètres à bord sont normaux.
And at the moment, we have no telemetry from the ATV because the receivers are off, but they have established the communication links which are necessary in order to get the telemetry to Toulouse once it has been separated from the Ariane. And this involves the TETRAS satellites. These are NASA satellites orbiting the Earth.
And once it docks, ATV will have several different tasks.
After final preparations at Europe's spaceport in Kourou, ESA's latest ATV is bound for the International Space Station, the ISS. With already 4 successful ATV missions, this 5th vehicle marks the end of an era, since it is the last ATV ever built. ATV-5 has been named Georges Lemaitre, as a tribute to the Belgian priest and scientist who is considered as being the father of the Big Bang Theory. It will once more be used as a supply vehicle to the ISS and will be the heaviest spacecraft ever launched by the European Space Agency.
We have, of course, as for any ATV, a different cargo composition compared to the previous missions, and the peculiarity which we are also proud of for this last mission is that for the first time we will have the full load of potable water, about 850 kilograms, to be uploaded for the benefit of the SS crew.
ATV-5's dry cargo load is over 2.6 tons, with over 1.1 tons loaded into the ATV during the so-called late cargo access operation, when the ATV is already mounted on top of the Ariane 5 launcher. This 1,100 kilograms is more than double the late cargo load of the previous ATV load. Besides the usual supplies and scientific cargo, ATV-5 will also be embarking a new laser system for supporting approaches and docking to any target. An experiment based on new sensors.
ATV-5 has something very special on board, which is called the LIRIS experiment. It's a suite of optical sensors which are discoupled from the ATV functionality. They are just registering data during the approach to the ISS, and they are meant to allow technology advancement in the area of sensors, with the final objective to later on maybe dock or rendezvous to non-cooperative targets.
Once the ATV-5 is in space, it will rendezvous with the ISS using its sophisticated guiding system. Upon its approach to the ISS, the ATV's automated docking system will be activated and the Georges Lemaitre will dock to the ISS. The operation will be supervised from inside the ISS by ESA astronaut Alexander Guest.
ATV-5 will be attached for 6 months at the International Space Station. During that time, it will provide the altitude and attitude control to the ISS. And when all the dry cargo has been removed from the cargo carrier, it will be filled step by step with trash cargo. And after the 6 months, it will undock from the station and will do its controlled destructive re-entry over the South Pacific uninhabited area.
With ATV-5's re-entry happening at a less steep angle this time, it provides an opportunity to more fully understand the behavior of the spacecraft. This will be monitored both from the ground and from the ISS, gathering important data for the future destructive re-entry of the ISS itself. This last ATV dive will mark the completion of the ATV program. After 20 years of work on the ATV, ESA will put its investment to good use for future endeavors.
Running a program with 5 flawless ATV missions is an achievement we can be very proud of. The good thing about us, it's not a real land. We are going ahead with a service module which we still consider as a derivative of ATV. In that sense, there is a perspective.
In the near future, ESA will take part in the NASA Orion program by building the service module of this manned capsule mission using the ATV module as a basis. And the automatic rendezvous technology will be key for future space exploration missions.
Very exciting technology there. It gives you goosebumps. And you can see on the top right-hand side of the screen, we climbed high into space. We've plateaued out, heading towards our orbit. We've had acquisition of signal at the base in Santa Maria in the Azores. We are heading out across the Atlantic now towards Africa. How different is the cargo on board Georges Lemaitre, Charlotte, compared to some of the other ships?
Each ATV has had a different cargo configuration, and about the only thing that is constant between all 5 has been that's the end of the first boost.
The end of the first boost of the upper stage, which has switched off its engine. And we are now entering what we call the ballistic phase. That means no propulsion. We've switched off our engine, so we are traveling under our own steam. Why is that, Charlotte?
Well, basically, we are now pursuing the trajectory caused by the first boost, and we are waiting for the right moment to perform the second boost, which will put us on the circular orbit, which is our separation point.
And this ballistic phase, or coast phase, is going to last about 45 minutes, and then we'll switch our engine back on again. The International Space Station is huge. It's about the size of a football pitch, way too big, of course, to launch it in one piece, so it has to be assembled in space.
Yes, you could see the ISS in a way as a giant Lego. The first piece came up in December 1998, and the next piece came up just a few short months thereafter, and
Tous les
teams
paramètres à
have
bord sont
been
normaux.
building upon it ever since. And it has been evolving with each assembly flight, and of course many of the assembly flights were based on the shuttle because it was the only vehicle that could lift it up.
And ATV and the ISS are only part of the European Space Agency's remit.
And welcome back to Mission Control Houston. We'll have you here for a couple of minutes for a few updates from inside the room. Continuing our coverage of ATV-5 George Lemaitre's flight to orbit. As you just heard, we're in that coast phase. The second stage engine shutting down for about 45 minutes. It'll continue on this ballistic trajectory before reigniting. That'll then continue to raise the orbit, sending it into a circular orbit, and then setting it up for that spacecraft separation. At that point, ATV-5 should be in an orbit of about 161 statute miles, traveling well over 17,000 miles per hour. Following that, it'll be on its way for a 2-week journey towards the International Space Station. Again, that fly under coming just a few days before docking to test out some new camera equipment for laser range finding before eventually docking with the station coming up on August 12th. As mentioned, this the fifth ATV. Again, here real quick, you can see the times, the pertinent times for that docking. Launch being done successfully today at 6:47 p.m. Central Time. Our docking coverage will be here on NASA TV. It'll kick off at 7 a.m. Central, with the docking expected to come at 8:34 a.m. with ATV-5 hooking into the aft end of the Zvezda service module. So be sure to tune in about 2 weeks for that. But as mentioned, this is the fifth ATV vehicle, each one being named after an important scientist with contributions to the advancement of space science, astronomy, physics, the wide gamut. This one named after Belgian professor and Catholic priest George Lemaitre, well known in academic circles as one of the father, if you will, of the theory of an expanding universe. Actually engaged in research at a time with Einstein, counteracted or contradicted Einstein's theory of a static universe with his observations that the universe was in fact expanding and was not static. Ended up becoming the prevailing theory that we now know and follow today, starting off with the Big Bang. So George Lemaitre, a very important figure in what we now understand to be true about our cosmos. This is the fifth ATV. The first one launched back in 2008 was named the Jules Verne. That was the first flight to the International Space Station. Since then, 4 have completed their flights successfully. ATV-2 named after Johannes Kepler, 3 Eduardo Amaldi, and 4 actually being named after Albert Einstein. Fairly regular launch schedule too. ATV-2 back in 2011, 3 in 2012, and 4 just a year ago in May of 2013. The vehicle responsible for delivering a very large amount of cargo and fuel, water, supplies to the International Space Station, also serving as that reboost capability once it's up on orbit. Here you can see what it looks like once it's attached to the aft end of Zvezda. It takes over as one of the main sources of reboost, propellant sources for the International Space Station while it's docked. And so we'll be looking forward to having that on orbit to help lighten the load off of the Progress and these Zvezda vehicles.